Welcome everybody to Data Crunch again. Today we have René Morkos on the show. I'm here to talk about some interesting things in machine learning AI, specifically in the construction industry, but expands to a lot of different areas as well. He's a professor, adjunct professor at Stanford, CEO of a company called Alice Technologies. But René, maybe I'll let you introduce yourself and tell us where you've been, what you're doing, and we can go from there.
Yeah, absolutely. Really great to be here. Thanks for inviting me, Curtis. My
Sure.
background is I'm a construction guy through and through. My dad gave me a good piece of advice when I graduated high school. He said, "Son, study anything you want, just don't do civil engineering." I was like, "Got it. I know what I'm going to dedicate my life to now." And so, uh, yeah, I like building stuff. You name it, I built it. I've done underwater pipelines, $350 million gas refinery in Abu Dhabi, in the middle of nowhere. I was in Afghanistan, as a private contractor. Worked for a German company down there. Designed, built, procured my own jobs. I worked my way up the ranks. I started as an assistant site foreman, became a site engineer, became a project manager, then was running several projects. Then ended up doing a PhD at Stanford. Kind of was doing 6 month on, 6 month off. So I kind of funded the program that way. I was really consulting during my 6 months off. I started getting interested in how do you run companies, and I started working I was doing a lot of work on like cost coding, daily reports, monthly reports. BIM was a big deal, back in this was 2010. So yeah, and long story short, ended up developing Alice, first construction, generative construction simulator, a tool that can generate millions of different ways of building a given project, really to solve the problems that I wanted solved when I was in the construction site. Our field does not have a solution that answers the most fundamental question, which is how do you build a darn thing in the first place, or what do I do if there's a delay, right?
Yeah.
And my thinking was always that, which is I want to come to the office in the morning, do my site walk, right? I want to plug in what happened yesterday in the computer and let it do all the thinking for me, right? I want to finish my coffee, and then it spits out, hey, here's what you need to do today, and if you don't do this, here's how late you're going to be, right? So that's kind of that's the background.
So it sounds like you started in construction and civil engineering, and then how did you get into the AI field from there to figure out how to solve this problem?
Yeah, it's a great question. I think that my environment was definitely, part of it. I mean, I studied at Stanford, which is, Silicon Valley. And so, everything's a nail to hammer, right? So to Silicon Valley, everything's a software problem that needs to be solved in
Uh,
software. There's definitely a limitation to applying that to everything in the world, I think. And various discussions have come up recently in the press about that. But for me, my background was construction, right? I took a course, back in high school for Pascal programming. Uh,
hmm.
did another class in basic programming, the language, and then did a class at university, C++, right? And then a class in Java, right? But so I've taken like a few classes in kind of basic programming languages. I think that the one class I took, which was an introduction to AI at Stanford, was,
Hmm.
was like a big um, eye opener to me. It really, it's an introductory course, but it really, I think, helped shape how I think about problems, how to apply, machines to solving them. And then if anybody's listening to the podcast, like it's all available. Like Stanford's, CS 106A and 106B is on YouTube, right?
Yeah.
You can literally take it. Nowadays with Coursera and Udacity and all this stuff, like definitely worth, 3 months of a couple hours a week of seeing how do computers work. Right? And so that's kind of how I got to it, I think.
Got it. And this was born of this need to solve the problems you saw in the construction because you were so deep in construction, right? And there's got to be a better way to solve these issues.
Chris, like a lot of people don't realize that your rear end is on the line when you're building these things.
Hmm.
In a big way. Like I've been on jobs, that we're looking at 50,000 euros of liquidated damages per day. 50 million euro job. You wake up today, you're $50,000 short. Tomorrow, that's 100. Day after, 150. Day after, 200. End of the week, you're at $250,000. You can imagine like the mood, right? And on the construction side when this starts happening.
Yeah.
Because you quickly burn through your profit margin. Now you're losing money. And so to me, like what I always wanted to do was to help that person, that girl or that guy or whoever it is that's sitting there dealing with that situation. That was the objective, to get like, and the way I kind of view it, right, is people today in construction are trying to fight a war with muskets. It's I'm sorry, it's kind of ridiculous at what, a lot of the tech that they're being given, right? These Gantt charts, right? And it takes 16 lines of code to write up a CPM algorithm, 1/6. And we've been stuck in that technology since 1961. Like, there's got to be a better way, right? And every other, like, I've hired software developers that have come to the company and said, René, everything in the world uses AI. I remember this one guy specifically said, everything in the world uses AI, like satellites, computer games, cars, like everything. How are you telling me that an industry the size of construction isn't using artificial intelligence? Like, he wouldn't believe me. And I'm like, I'm not kidding you. I swear to God. Like, here's how this field works. And so, but it's happening. Since 2017, right? All this money is being poured. Construction tech is now the sexy thing and sexiest thing in the world, right? Which is great. I'm so happy to see all these startups, sprouting up and being successful, right? Yeah. Fieldwire just sold to Hilti for $300 million. God bless those guys. You're starting to have, multi-$100 million exits, right, in our field.
So tell us about this approach. Then it's AI we've seen applied to other areas. Like you said, construction hasn't seen it in a long time. There's starting to be more interest in the space. What is your approach? Because you've been there, right? You've seen the deep problems. Like, how does this get solved?
So there's kind of like the North Star was always that. The North Star was we set out to solve the problem. We didn't want to build a photo sharing app. We didn't want to build some file sharing thing. We didn't want to build some forms that you fill out. Like, we didn't want to take an existing process and digitize it. That's, and we realized that was going to be a lot harder, a lot more difficult. There's a lot more unknowns. Like, we spent 3.5 years with core R&D. Like, there was literally, 3 guys in the basement kicking this thing over and over and over and over and over again, and it caught fire more times than I can remember, Right. So the approach was for you to apply AI to a field, you first have to convert it into an AI formulation. And that's kind of what I did in my PhD. Our field actually doesn't have a developed conceptual model. So what is a conceptual model? It's like people would come to me from the computer science department and say, hey, I'm interested in working in construction. I'd be all like, oh, that's great, really. Like, thanks for being excited about our field. And they'd say, hey, can you put me in a book I can read so I know, like, what are the pieces of the puzzle I have to put in the computer? And I'd always say, oh, we don't really have one. And this is, what do you mean? Like, no, I'm looking for a book that will tell me, like, I have to think about labor and equipment and materials and production rates. And, here are the pieces of the puzzle. And I'd say, well, we don't have something that, like, specifies it in that way. You'd have to read a whole bunch of books. And so one of the things I did in the PhD was really develop this conceptual model, right? Like, here's a question I like to ask: is the production rate an attribute of the crew or the task or the element that's being worked on? Right? Because carpenters can install formwork or they can remove formwork, and they can do it for walls or slabs, right? So these are the sort of questions that you get to think about as a PhD. You're earning $24,000 a year. Your budget's pretty simple. Beer and pizza, right? But you get to spend, 16 hours a day thinking about that, And so for us, the way we did it was we basically figured out how to formulate the construction problem as an AI problem, right? Or as an algorithmic problem. That is super powerful. That is what I did in the PhD. And I remember going to my advisor and saying, like, hey, like, this thing's a key. And he was like, yeah, whatever. And I was like, no, like, I swear to God, this thing's a key.
Pay attention.
Yeah. And we proved it. You can use all these techniques to solve the darn thing. And so, yeah. we basically, applied a whole bunch of stuff to it and figured out the best way to do it. Yeah.
Got it. And 3.5 years later, so 3.5 years was sort of the R&D phase, right, with this.
So
And tell us about when you started to use it. It's in production now, right? People are using it. What is the mental shift they have to make to think about this problem in a different way, right? Because I imagine in the industry, people aren't used to using AI, right? So they have to kind of think about things in a new way.
so the mind shift is an interesting question. Here's what we've realized about the software we've developed. It's a new way to think about construction. I had a bunch of, very high-powered consultants use it, and then come back to us 2 weeks later and say, "Hey, this thing's not just a software; it's a new way to think about construction." And I kind of smiled and I was like, "That's exactly what it is." So the point you're making is an excellent one, which is you can learn the software in a day and a half. There's nothing to it. I'm not kidding you. Like what tasks do you need? What resources do you need? Right? You want to build a slab. Here are the 5 tasks. I'm going to need some carpenter crews. I'm going to need some steel crews. Here's some durations or production rates, whichever way you want to set it up. So the setup or the software is simple. The mind shift, that takes in the order of weeks, because you're going from a universe where there's one option that took you a long time to create, that's full of errors, and that's really hard to redo. They're suddenly going into a universe where there's lots of options, right? And there's lots of options, and you now have to think about not just comparing a solution to a solution, but groups of solutions to groups of solutions, if that makes sense. You're also, like, in some ways, it's been interesting to see, like, from a cultural perspective, you're a lot less vested, in that one solution because it didn't cost you anything. So it's been interesting to see that sort of mind shift or mindset. Like, the thing that we see with AI over and over and over again at Stanford is that what it does is it becomes the thing that does the crunching, and the human becomes the thing that sets up what needs to be crunched and interprets the result. And a little while later, somebody develops the next version of the technology, and so what used to be the setup and the analysis now becomes part of the AI, and the human takes a further step back and sets up, again, what's going to be crunched and then interprets the results, if that makes sense. One of the head innovation guys at Exxon told me something really interesting, which was a guy called Vineet Verma. And he said, what technology does is it makes the art of yesterday into the science of today and unlocks the art of tomorrow. And I was like, bam. Like, I was like, that's exactly it. Mm-hmm. When people hear about Alice, they're like, oh, is it going to take my job? Or is it, and it's like, in some ways I almost wish, right? Like, we'd have a much easier life. But like, if you look at since the Industrial Revolution to now, it's not like we're working any less hours, right? Yeah. And so what Alice will do is Alice will be able to build your project 6 million different ways. 1 crane, 2 cranes, overtime, no overtime. Very in production rates. Like, you can tweak a variable, add a crane, and Alice rebuilds it for you, right? So that's kind of the you can say, hey, the material's delayed, and Alice will go through 6-month sequences. So that's the power of the technology.
How did you go about training algorithm like that? Right? Is it looking through a bunch of records of past construction projects, and like how do you approach that?
There's nothing in my opinion to learn from currently.
Huh.
That's the thing that I think, because of our field doesn't even have a construction conceptual process model. It's a bit of a mouthful, but we don't have like a worked out version of what are the pieces and how do they interact, right? And so, like, what I'm trying to say is that we don't even have the conceptual model, right? Let alone a bunch of software that are running on a common conceptual model that are learning from each other or learning from the results of other performance, etc. Like, we just don't have that. And I had someone about 4 years ago come to me and say, hey, very sort of, how should I put it, self-confident gentleman. And he said, I have 40,000 Primavera schedules with their, percent complete. And if you're lucky, I'll sell them to you. I said, okay, well, let me go think about that. And I spent a couple of days sort of mulling it over, and I got back to him and I said, I really appreciate the offer, but I don't know how I'm going to extract value out of it. He said, what do you mean? I said, well, your schedules, are they tied to a bin model? No. Are they resource focused? No. So the only thing I'm going to be able to glean from it is the description of the task, and that's not standardized. So, there's like this, there's not enough encoding in the data for you to be able to glean that out of there. At least I'm not aware of it. I'm sure there's somebody, listening to this somewhere in a basement in Silicon Valley or, other innovation centers around the world thinking, oh, no, I'm going to prove that guy wrong. I know exactly how to do it. Right. But, there's in my opinion, currently our field doesn't have that data set. And so Alice learns from herself, which is how we got around that problem.
Got it. So are you trying to build a data set like that with Alice currently?
Yeah, absolutely. Right. I think it would be great. Like, what I would like to do if I had some time, because I have kind of two hats, right? One is the CEO at Alice and the founder, and the other is a young professor at Stanford. And so, and I really try to differentiate the two and work on both. But what I would really love to see is a conglomerate of construction organizations, general contractors, owners, schedulers, so on and so forth, estimators that get together and say, okay, you know what, let's kind of put some resources at this. Let's build out a conceptual model that everybody can use, that we all agree on. Let's share some data sets. Let's start putting stuff up in the cloud, right? But it would be great to do that. I'd love to see that. For sure.
Got it. Yeah, that's interesting. And I want to get, and I mean, you mentioned how this can change the construction industry, but I'm really curious. This R&D phase that you were talking about. We haven't talked to a lot of people on the show that have necessarily done something like that. What were some of the biggest challenges or things that you hit in this phase? Like, what would you recommend if someone was going to do this in their industry for their own stuff and come up with some conceptual model and try to do what you did in construction? What would you say to them?
So we've gone through a very, almost unique journey. And here's why. We went from conceptual research, which is, hey, what are the pieces? Like, do I need to think about labor or crews or individual people on crews? Or, what are the pieces and what is the information that is attached to each piece? That's conceptual research. We then moved into theoretical research. So to me, theoretical research is, well, how do those pieces interact? So if a crew works on a component and an element, what's the output of that? Is it considered a task, or is it an operation, or is it an activity? Is there any difference in them? Right? So that's kind of theoretical research. How does it interact? Theoretical research. Then we do prototypes, right? Because without a prototype, who's to say that the theory and the concepts are correct? Prototypes. We did commercial product and commercialization. So that's the journey that we've been on, or I've been on for about 13 years now. So. The advice I would give is as follows. It is remarkable to what extent things are not solved yet. Like, if somebody's sitting there and you're like, oh, because I have literally been blown away by how many times I've thought to myself, like, oh yeah, I'm sure that's all worked out. Like, somebody somewhere has worked this out. Somebody somewhere has figured this piece of the puzzle out. Like, I don't need to go think about it because it's all been done. And I think that's kind of maybe the biggest piece of advice, which is you will be surprised at how much of it has not been done. If you start, slowly, and you have a whiteboard and you start iterating on the idea, and it's, I would recommend, go read How to Fly a Horse. Best book on innovation I've read. It was recommended to me by one of our investors. I read it and I was like, yeah, that's what my life is like. What that book will tell you is that, people think of innovation as like, oh, some really smart person going, oh my God, I got this like great idea, bam, right? Whereas it tends to be, quite the opposite. You go through, iteration after iteration after. You solve a little problem by trying 6 different ways to do it, and you solve it. And then, you unlock 3 different ones. So you try, 6 different ways to solve the first of the 3, and you figure it out. And you try 4 different ways to solve the next one, figure it out, and so on and so forth. And that's, if you can stick to that, and you can stick to that for, say, 2-3 years of your life, then you'll start to get something that's valuable, and will start to kind of have some traction. But that's basically it. It's not some, hidden realm for some, privileged few. It's not like you need a lot of money or a lot of intelligence or a lot of whatever it is. It's just perseverance and sticking to the darn thing, and sticking it to it for 2-3 years, and keep iterating on it. And after that amount of time, you will start to get stuff that's useful.
Interesting. How much of that would you say was deep domain expertise that you had versus like cutting edge AI algorithms, that kind of thing, when you're going through this process?
95% was domain expertise. 98% was domain expertise. Yeah. I'm good with algorithms. I've been good at math my whole life, right? I figured out solutions that would work, that were simple, right? But once we had it up and running, we brought in some heavier duty kind of folk to go lift that piece. Okay. But yeah, I mean, I think that what's interesting is that I feel that surprisingly one of the most important things, if not the most important things I did, was tell everybody what not to do.
In what way?
So, I've been on construction sites. So here's an example. Do you need to, if you have a simulation like we do, right, first in the world, runs lots and lots of different ways to build something, do you need to model movement? So I'm working on column A, now I've moved to column B. To somebody outside the industry, you'd think like, oh, probably, right? With Alice, we knew that, or I knew that you don't need to model that. When you're on a construction site, you don't think about crews moving from A to B or B to C, right? And so that was kind of, I think, an important piece of the puzzle that the domain knowledge brought, which is, what do you not need to focus on? Right? Alternatively, even like, what do you need to focus on?
Right. Really interesting. And what do you think this is going to do for the construction industry? I mean, this is, what would you say, order of magnitude or more improvement in efficiency or performance? What's going to happen?
You're reducing costs by 13% for labor and equipment, and your construction durations by 17% on average. That's what you're doing. And the reason you can do that is because your effort to generate a schedule, or a simulation as we call it, is 800 times. It is 800 times less effort to schedule, reschedule, etc. That's the paradigm shift. And the way it works is that the way to think about it is, people are trying to fight this war with muskets. We've built an F-16 jet. It still needs a pilot. That's kind of interesting. Sure. It doesn't fly itself, and I don't know how to do it. Even with all this time and effort and all these things that I've read on it, and all the top AI in the world, you can't. You still, the trick is not removing the person with the construction experience. The trick is leveraging that construction experience. Interesting to watch. See, how do you take that person's construction experience and let the machine leverage it, use it? Let the person now has a way to guide that machine with their experience to generate lots of solutions. It's not AI, artificial intelligence, but IA, intelligence augmentation. The software is being used in some of the largest projects in the world, with some of the largest construction companies. We're involved in the Edmonton Rail, 2.6 billion. We're involved in many large infrastructure jobs. I think we've done about $30 billion worth of construction managed through the system in the last 6 months alone. And
that's awesome.
Yeah, it's definitely an incredible piece of technology. So.
Great. Well, René, we appreciate you telling us about it and about your journey, and hopefully there's much more to come.